Hello guys, before we proceed with the problem in development length, let's try to understand first the procedure on how to determine the factors of safety uh, psi um, T, which is the reinforcement location factor. So in here is a problem on how to determine whether the bars are top bars or not. And normally we have here um the given values as the clear cover, which is 40 millimeters, the diameter of all main bars, which is 20 millimeter, and the diameter of the stirrup, which is 10 millimeter. So for other problems, your top clear cover, bottom and the side may not be the same. Okay, so the computation will be a little bit longer, but the procedure is similar. So remember the definition of our top bars, in which this is defined as such, wherein the location has at least 12-inch or equivalent to 300 millimeter of concrete cast below it. Okay, so this is the key parameter to compare with, so that you may conclude whether the bars are top bars or not. So all we have to do is to simply check on the distance from the bottom surface of the bar, the main bars, up to the extreme bottom of your beam. Okay, so if I have here now your bottom. Okay, so I will simply measure all the distances from here, okay, up to the bottom surface of the beam. Okay, so these are the distance that I need to know so that I may be able to compare it later on the value of 300 millimeter. Okay, so it's a simple dimensioning problem, wherein we simply use the diameters and the covering to determine the values. Okay, so for these bars here, I will call them uh, my first layer bars. Okay, so this I call my layer 1. This I can call my layer 2. Okay, and this I can call my layer 3. Okay, so this is 1, 2, and 3. So for layer number 1, since they are just in one layer, I can solve now for this distance by simply subtracting some distances here from the top up to this point from 450. Okay, so this is simply a very easy computation of 450 subtracting the clear cover plus subtracting the diameter of the stirrup and subtracting the diameter of the bar. Okay, so this is now my simple formula where 450 is actually the total height of the beam. Okay, so this will now get me values of 40, and this is 10, and this is 20. Okay, so 450 minus 70 is simply 380. Okay, millimeter. So for my layer 2 bars, I can now start subtracting 450 minus again the clear cover okay, or better if I just get the location of this layer 2 bar from the top, which is normally at mid. Okay, so this layer 2 is at the mid height of your beam. Okay, so normally the distribution of your reinforcement on layers must be symmetrically placed such that your layer 2, which is in the middle, must be placed at the mid height. Okay, if it is not mentioned in the problem, that's the normal. Okay, so this is now your, from here up to the midpoint of that bar is simply 1/2 of your 450, which is 225. Okay, so I simply subtract this by 1/2 of h and then subtract it by 1/2 of the bar diameter. Okay, it's easier. You can also do a format just like the first one, but it's much harder. Okay, and this eventually will give us 450 minus 225 minus 10. Okay, equals 10 is 1/2 of dB, so this becomes 450 minus 235 becomes 250 millimeter. And for the last, although it's obvious that it's not a top bar, let us compute it. So this becomes 450. Okay, this time we are now subtracting what? On the basis of the topmost fiber up to the center, or the center of the bar, is what? Is a much difficult task to make. Okay, so we can actually turn around the solution. So instead of referring to the top, we can start from the bottom. So just like what we did on the first. Okay, so it's simply the clear cover. Okay, the clear cover plus the diameter of the stirrup plus, okay, or simply the diameter of the stirrup, which is equal to 40 plus 10. So this gives us 50 millimeter. Okay, and the rest is simply comparison. Is this greater than 300 or 12 inches? If the answer is yes, then this is a top bar. Is this greater than 300? No. So the answer is not a top bar, or it is another bar. Okay, so other bar. And for the last, this is less than 300. Therefore, this is again an other bar. Okay, so if you look into the solution, it's just a matter of trying to solve for the dimensions. You can do it any way you want it. But it's not a difficult task to do. So I think uh, it's just a matter of knowing the parameters as far as the clear cover, the top, bottom, and side cover are concerned, the diameter of the bar, and the diameter of the stirrup. Okay, so that's how to determine whether the bars are top bars or not. Okay, so thank you for listening.